All right, we're here, episode 221, back to basics with observability part 2. I think we had done this a few weeks ago and we ran out of time and it was so good we decided to come back with a second get up or second get go. Holly is here somewhere. She keeps popping on and off. She'll be with a stable internet connection in a moment. Oh, there she's going to turn your video on. There you are. Hey.
Computers were a bad idea.
Yeah, computers are a bad idea. We're still on the fence about computers. So what do we have any kind of news? I know we got DevOps Belgium going on this week, so most of our team is, or a good portion of our team is there. I was at Dev to Next in Colorado last week. That was a pretty good conference organized by Venkat. So, but yeah, any other news? I know I was just talking to Bruno. This is like 9 a.m. my time on a Monday after being gone for a whole week. So I'm still catching up. I don't know what happened last week yet.
Yeah, last week we had a bumper edition of news because we talked all about DevOps and all about the various releases. But I think after all that news last week, this week, no new news other than DevOps is happening.
Yeah, no news is good news, right?
Yeah.
All right, so we got Bruno here today. Bruno, what are we going to talk about?
Hey, hi everyone. So last time we had a bunch of things to talk, but we didn't have enough time, and we had enough material, so we kicked the second episode today, and that's what we are going to see. My plan is to start exactly where in the point where we left last time, and we go from there.
Do you want to just give a little kind of quick summary so I don't have to pause this and go rewatch the last one? And
yeah, sure. I'm going to do that as soon as I start.
All right, awesome. All right, do you need your stuff, I assume, here, huh?
Yeah. So this is my code from last month. And
can you make it a little bigger? The font size a little bigger? Sorry.
Yeah, I can try to get it. Is this enough?
I think so.
Okay.
Holly, does it look okay? Yeah, I think it's okay.
Okay, so we had we were using LangChain4j to create a chatbot, our assistant, where we can send it questions and he answers us back. And we created a REST resource to interact with that. So we had a chat endpoint where we would send our questions and we would receive our answers. And we created that chat service and we had a bunch of metrics that we created. So we wanted to count the amount of chat requests. So we used Counter for that. We used Timer to check the latency to see if the responses had the expected time, so we can follow them. And also the size of the payloads that we are sending to the chatbot and receiving from the chatbot. And that's where we left last week. So we talked a bit about tags and dimensions. We used the meter provider for that, and we also so we were using actually a version of Quarkus that was based on main, because we were using a feature that I wanted to showcase, but today is working on the 3.28.2 as of 3.28, I think it's available everywhere, which is the Grafana dashboard auto-loading into Grafana. So if you create a Grafana dashboard file, JSON file, and you place it inside a meta-inf Grafana folder with Grafana minus dashboard name something, it will auto-import that into Grafana. And when you load Grafana on dev mode, it will, well, your dashboard will be there and you can start using it right away. So cool. No need to manually import. Yeah, it's really, really nice.
Yeah, it works really good. I've actually started using it myself too.
Yeah, and it saves a lot of work. And today the promise was that we were going to use queues. And I'm going to use a queue system to store messages that then we are going to fire at some point of our choosing. And we are going to use Micrometer to monitor that queue. So let's start by creating here, let's call it queue service, very creatively.
Because we all know naming things is like the easiest thing ever, right?
Yeah. And because, well, all this boilerplating takes some time, I'm just going to paste here some skeleton. And for our queue, I've decided to use a concurrent linked queue. And so we can enqueue messages. So messages are actually here records of message that have our prompt question. And we also store the moment we created the message, because it's going to be super handy later on. And we also know the depth of the queue. And we are going to implement how we process each time we get something out of the queue. So this time, so we want to use our chatbot. So we need to inject our service here. So we need a chat service. Chat service, that's fine. And we can just add it to the constructor. It will be injected because this is an application scope bin. And here we can just create a response as a JSON map. Let's say, oops. Let's say we want a question that was, well, I imagine that we need to take the message from the queue. So we are going to poll, because poll on queue systems will get the message and also remove it from the head of the queue. So it's a first in, first out type of queue. And we will get our prompt. And then we need the answer.
Doesn't poll also blocks too if there's nothing in the queue, right?
No, actually it will return null.
Okay. Yeah, there's another
which is
one,
a problem. Right? Yeah. So which is a problem that we will need to solve as well. So poll. So it would look something prompt like this. But let's just create a variable for this and replace.
Yeah, because otherwise you're going to pull two messages. You're going to have a question and an answer that goes to the next message.
Exactly. So we just want to get one message. Actually, I want the whole message, not even this. So yeah. So answer question message.prompt. Message.prompt. Yeah. So right now we would, each time we try to drain a message of the queue, it would take one and execute the chat service, and we would get a response. So if you remember the chatbot from last month, we would interactively send a message using Swagger UI. Now we can add a bunch of messages to Swagger, and then they will queue, and then we can fire them at the moment of our choosing. Okay, now we can monitor this. And one of the first things that people want to know is how many messages do we have in the queue, which is so we need to know if first we are receiving something in there. The second is, is it growing infinitely until it blows up? So knowing the size, it's actually a very important thing. And in order to do that, we need a registry. We will use micrometer as well, like last time. So registry that will be injected. So registry always should be injected. There's a way to get the registry from global registry, but that's not good, because it will bypass all the logic that we have in Quarkus to around the registry. So we have registry, and we can create metrics around it. So last time, so on the chat service, I know that we created all the metrics in the constructor. For the queue service, just because we want to be different, we will do a post construct. So post construct, you can create a method where you initialize everything you want after the bin is created.
So is there a difference or any like gotchas as why you should do it one way or the other?
So typically, everything that you put in the constructor must be available at the time of injection. So, and if you do post construct, you know for sure that everything. So first, all the bins are available already, and they should be. The system should be on to work upon. People usually do things like populate some structure. Imagine that you want to cache, want to look up something on a database, and you want to cache it. Here would be a nice place to do that kind of operation. And we are creating metrics here. So we could do it in the constructor, but we are doing it here. So we are going to create a gauge, funny name gauge. So we are going to no gauge, micrometer gauge, yes. So gauge, in my language, I would read this as gauge or something like that, but it's well, gauge. It's gauge is you know the speedometer in the car, where the speed has a value, an instantaneous value at every given time. A gauge does exactly the same. So micrometer, when it tries to export the data, will probe the value of a certain attribute, and that's what it's going to use. And we need a name for this metric. Let's see, demo queue, and we want to see the size of the queue, so let's go for depth. And we need to teach the gauge a way to retrieve the value. There are multiple ways. One is to pass the object, and tell it a function that it needs to execute, for example, queue size. So this would work, and it's elegant enough. Another way would be to just get a runnable and execute queue size. You execute the object.size. Well, let's go with the previous one because I think it's more interesting. And as all the metrics from before, we need a description. So we should add this description for all metrics so people have an exact idea of what we are measuring here. And in this case is how many AI prompts are waiting to be processed, because they are in the queue. And let's go for base unit prompts. And we are going to register in the registry. So no need to associate this with a variable that we need to increment later in the code like we did with the other metrics, because this one is defined like this, and it's fine. So another thing that we can do with queues is count how many messages we have processed. So we added a bunch of stuff in the queue, and then we need to make sure that we are actually doing something with those messages, or otherwise they will be sitting there. This is another common problem with queuing systems. So let's get the counter, pretty much like we did last month. I think I'm gonna continue saying last week forever. So demo queue processed. I'm being very careful with these metric names because I created dashboards that are based on the names that I'm defining here. That's one of the problems with semantic conventions is that if they change, you need to change the dashboards. So I'm trying to make sure that the data later will show up on the dashboards.
If only Quarkus, kind of like with Qt, where we can do compile time checking. If we could do the same thing with Grafana dashboards, that would be awesome.
Actually, now I think we can, because we can load this stuff automatically. So probably
Challenge
we can do that. Actually, that would be a very nice feature. So this is the total. Messages processed from the AI queue. I'm not going to put a unit here. I'm just going to register it on the registry. But now I need to associate it with a variable name. So I'm going to go with processed counter. And so create field. Yeah. So I can use that later. So, and in here, so I'm going to create a variable for this. And processed counter, I can just increment. That's it.
Maybe I asked this question last time. If so, I apologize. I don't remember the answer. Is there a reason you would do it this way rather than just annotate the method with @counted?
It's just because this is too easy. So counted, we have an interceptor that would wrap the call and would do basically the same. However, we can do a bit more fine-grained. We can do a more fine-grained metric this way. We're going to see how later. Another thing that we can measure on a queuing system is if we are taking a lot of time to process the messages. So message processing is fairly, we already have a measurement for that. Remember that we have the chat service answer, and this is wrapped on a chat latency record. So we have a distribution for these chatbots. So we are not going to duplicate that. However, we can measure how long messages are waiting in the queue before processing, which is also a very nice metric, because that way we can understand if we need to have more workers in there. So we need to scale or not. So, and to do that, let's go with not with a timer, but with the distribution summary, which is basically a histogram. We created the histogram last time, but it was based on percentiles. Now we are going to do service level objectives. So, and yeah, wait. So the magic is called wait waiting on queue. Yeah, that's fair enough. And this is the base unit. In here, we are going to choose milliseconds, and we are going to define a service level objective. So I have a bunch of them here. So I'm gonna force the values, and I'm gonna display why. So I want to know if things are taking a very short amount of time to process, like 30 milliseconds or 100, or if they take quite a very large amount of time. So let's go for 1 minute. So 60 seconds, or 10 minutes. So 6, 1, 1, 2, 3. Yeah, I think we can do that thing here, right? Yeah, and then of course we need to register this on the registry. And we are going to need this metric later in the code. So let's call it wait summary. So we create a field here, and then we can use things. So the first thing we need to know is, well, take a message from the queue, and before processing, we are going to measure how long did it spend in the queue. And we have that information because we recorded when the message was created. And basically, so on the wait summary, we do wait summary.record, how long it waited. And we need, so we are using milliseconds, so let's go for long. And the waited time is the duration, well, between the message created at and now in milliseconds, basically. So that's how long it waited. So we are going to record that. And this would work totally fine, but I want to add something else. So imagine that I forgot to do something really important, which is if the message is null, return something else. This would get me, if the message was null, if the queue was empty, I would get somewhere I would get a null pointer, probably right here, created that. So if the message is null, I can return a map and say to people that the status is queue empty. Yeah. But imagine that we get an exception here. So this would never be incremented. So we would have processed, message that were taken from the queue that we didn't count for. And this requires us to do something else. Let's say, let's wrap all these into a try-catch. And we can increment this only if we were successful. And if we were not successful, I don't know if you see where this is going. We could have a metric here. Actually, we can return something like map of status queue error or failed. Sorry. With, well, yeah, get message. Yeah, this is nicer. And we could, so people would think, okay, we need another metric here. No. We can.
The solution is always another metric.
Yes.
or a layer of abstraction that produces metrics, right?
Yeah, so we have a meter. So we used that before. You see, on the chat, when we were on the chat service, we had a meter provider. and we are going to use that.
I just thought of an interesting, like for a part 3 session. Just because it feels like we're mixing a lot of like business logic and stuff that's not related to business logic together. So extracting it out and like doing interceptors and all that fun stuff.
Yeah,
be an interesting advanced topic for another day.
Yeah, well, if we start with the advanced, we can have a season 2. Okay, so right now I don't know if you checked, but right now I don't have a meter anymore. I have a meter provider, so I'm not registering right now. I will register. I will defer for later that, and I'm going to say when it's successful, I need to add a dimension. So I need to add a tag that says that the status is success. And then I can increment. The same way, if I have an error, I can now say that the status is failure, and I will increment it on failure. And when we sum all the counters, we should have the total number of messages that we took out of the queue. And when things balance out, the number of other messages to the queue should be the same that we removed. Actually, we don't have a counter for other messages, but I think it's more important to understand what happened to the message that end up in there. Okay, so let's see how this works. I'm gonna, before I start the server, I'm gonna add a property that I forgot last time. So if people remember, we are using micrometer. However, we are seeing everything using OpenTelemetry because we are using the Quarkus micrometer OpenTelemetry extension. And this extension has micrometer, has a bridge that sends micrometer data to OpenTelemetry, and then the unified telemetry gets out using an OpenTelemetry exporter. And the exporter default time to export metrics is 1 minute, which is quite a lot. So I want to reduce it to 1 second. So it's snappier, what we are going to see on the dashboard. So let's kick our dashboard here. So I'm going to start it actually. Yeah, and let's see. So this will start Quarkus. We'll start the Grafana LGTM extension that we added last time here. And this will allow us to see our metrics in there.
Hey, Bruno, I gotta ask, do you have a cat?
Yeah, and my partner just left, so she's asking for her. So
she sounds angry or wants to be with you.
Yeah, Eric and I, we were both just sort of like doing it. Do we need to go to attend to a cat? And then sort of trying to work out by elimination. Is it your cat? It's not my cat.
Yeah, it's my cat.
Yeah, you probably saw my video drop off. My cat was being a pain and wanted to leave. Of course, whenever you shut a door, they want to be on whatever side they're not on, right?
Yeah. So the server started, but I forgot something. Actually, let me show you. So this is cool enough. I can show it to everyone. So retry. So I have the dev UI, and I have Swagger here. And when I start Swagger, I have the endpoints that I have now. Last week chat, hello, because we based this example on the code Quarkus that had this hello example. And we forgot to add our endpoints to manage the queue. So the first one is the push. We are going to push a question to the queue, and we are going to receive that question and also the answer. So we need our queue service working in here. And we are going to pop a message. So we are going to join one. Yeah. Oh, and when we train, we get that. Oh, so when we enqueue a message in the queue, this add to the queue will return a Boolean. So what we are going to see here is that, okay, we added this message and it was enqueued with success, basically. Yeah, let's go for it. So it's not here. I'm going to just call some endpoint, and Quarkus magic will reload the whole thing when I reload this, and the endpoints are here. So I'm going to push a few questions. So remember that we created a chatbot with memory. So I was asking it, my name is Bruno. I was telling it, my name is Bruno. And so it's that's enqueued true. And now I'm going to ask it my name. What's my name? So my cat is called Syrup.
Yes, if this continues, we may have to take like a break just to have cat cam. Because
yeah. I'm gonna let her in. Okay.
If she does it during the day, mine is like 4 o'clock in the morning, is roaming the halls doing that.
So, and I should have an observability stack here. So let me reload this. Oh, it didn't work well.
it wouldn't be a live demo if it actually worked.
Oh, no. Vertex, Netty. I don't know what happened here. Let me restart the whole thing. Let me just be sure that I don't have a hanged Docker image somewhere. I think not. Well, actually, I have. Yeah, just a second, because this might be messing my whole system. So it's this one here. It's too small probably, but well.
It's always a dilemma when prepping for a live demo. Do you sort of reboot your machine and then you know you've lost all your state, including the state that was going to be needed for your demo? Or you sort of get everything set up and then try it once or twice, and then that just leaves something that's going to mess up the demo.
So let's see now if it works. Yay! Okay.
Hooray.
So there was an orphaned Grafana dashboard there. So now, hopefully, when I go to dashboards, I have my observability demo dashboard here that is bundled with the app in here and has all the metric dashboard for the metrics. So we were talking about queues. So I have this and this. And when I'm going here, yeah, she doesn't. I need to post the questions again. So my name is Bruno. It's okay. And then the other question, what's my name? And it's okay. And now I can pop things out. So I just execute the request, and it takes a while, of course. So my name is Bruno. It says, oh, nice to meet you, Bruno. How can I assist you today? And then it pops out the next message. So what's my name? And it remembers that my name is Bruno as well. Cool. And now hopefully we have metrics. I hope. Or not. Oh, yeah. We have metrics. Okay, so what are we seeing here? So the first is the size of the queue. So I added 2 messages. For a while, the size was 2. Then it decreased when I pop things out. And the total processed, here I have success. You see, I only have success. The other one is, I don't know why this last one shows up. I couldn't, well, my Grafana dashboard wizardry didn't enable me to just show one line here. So yeah. But if we produce an error, let's find a way to create an error here. So queue service, let's do some mess in here. So let's push this down. Let's push this down here and for later, and let's comment it out. So we will have a null at some point. So I'm gonna just reload the server. So I'm gonna just try some endpoint, and we can see here the service reloading.
I think it might pass because I think you might have left the original in as well, but we shall see.
Yeah, so, okay, so the original, oh yeah, you're right. It would have passed. Okay, so now if I pop something out, I will have an exception or something, yeah. So failed, we cannot invoke, blah, 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 but we also need a proper message because each time you restart the server, so you make a change, you do a call to an endpoint, the server will restart and load the new code, but we'll also lose the state of all the metrics that you had in there. So we need to add new stuff. So what's my name? It was added. At this point, it will not know my name because it's a new session. And I don't know the name because, well, you don't know my name. Okay, and now we have 2 lines here. So one for failure and another one for success. So forget all the data that's behind because that was accumulated by Grafana. But at some point here, when we added this new message, this was restarted, probably here, you see. So the max wait time is something that you don't lose, and it always increases, but at some point it went back to 0. But now we have 1 failure and 1 success, which is what we expect. Okay, so let's fix the code again. And let's do some fun thing with long-running tasks and asynchronous code. So, yeah. Who wants to do asynchronous code? Well, almost everybody needs it at some point. And
which is not the same as wanting to do it, just to be clear.
yeah.
Having to do it and wanting to do it are 2 very different things.
So let's create some long, very long job service. Yeah. Same again. I had some skeleton prepared here so we don't spend so much time boilerplating. So I will explain the details, but long story short, I have a long task that I will execute. I want to count how many jobs I have, so I have a job counter, which is basically a job index, which is an atomic integer that I'm incrementing to get the job IDs. That's it. And to simulate load, I'm just creating a thread sleep that goes from 3 seconds to up to 5 seconds. So it's a random up to 2 seconds here. Oh, and the random is a random. Yeah, so I'm using here the default execute, so an executor that doesn't exist yet. So I have this qualifier for an executor service that I'm going to add now. Here are my command codes. Usually you don't need to do this, but I'm going to do it because, well, why not create your own executor service and shoot yourself in the foot? No, it's a producer. I'm going to produce an executor. And yeah, So first thing, for the executor, I'm just go to executors and I'm choosing the new fixed pool thread pool of 4 threads. So this will create a thread pool with 4 threads in simultaneous. And when someone needs this executor with this qualifier, this executor service, we will return that. And we need to shut down it afterwards, otherwise it's going to create a mess. Usually don't need to do this, but I choose to do it because I'm gonna show you something next. And when we go to the long job service, this executor, well, we'll have something in there, and we can do something like executor submit some beautiful task that we have here. Okay, and this will run in a different thread. Each time this task is called, the executor will ship this to a different thread, and all the work will be asynchronous. Okay, cool. And for this task, Micrometer has a type of metric called what's it called? Long task timer. Okay. So task timer. It's created with the builder as well. Oh, sorry. And we need to give a name to things. We are going to call it demo long job. Again, a description. So long running operations. Oops. And this will actually, so this will measure the time that the task spent queued. Queued plus running. You will see this in play later. And well, we could tag it, no need here. And we'll use the registry that we injected here. And so the long task timer works a bit different from every other metric, as you can see here. So first, each time we execute, so the long task timer, we need to start it, and we have a sample for it. And we need to make sure that we actually always sample this out, otherwise it will mess our statistics. So it's good to have it in a finally block, so we make sure that whatever happens, we stop the sample. And that's it. Each time this executes, we will sample this. We will have samples for each of the execution, and we will have it in the dashboard. But actually, this long task timer has a few other cool features. Let me show you. So if we start the Quarkus logging log, let's print some log of what's going on here. So we have a job ID. Let's see, for job ID something. So job ID has stopped and took these milliseconds, And we have X tasks running. Okay. So, and then we can add the ID. So we have the job ID, and then how long it took. Whoops, maybe a P here. Yeah. So we have the sample, and we can check the duration, the current duration of this, and we have milliseconds. Then the long task timer also gives you the number of current active tasks in there, which is super handy. We'll see later why. Okay, so this should work. Let's restart the whole thing. So let's call the one endpoint, calling the hello. And it restarted. Excellent. In 1 second. Oh, of course. We need an endpoint to call the thing. And we have this long start, which will use our job. It will basically call our method here. But all this will happen asynchronously, so the actual method will return right away. So I'll restart the server, reload the UI. Now we have the long start here. And when we do execute, so job 1 started. If we do a bunch of them, you see a bunch of tasks. Let's do 20. And then, so the queue doesn't have anything, but I have here the long job. And you can see that you have active tasks, a bunch of them. And as they are being consumed, the number of active tasks goes down. And you have the long job duration. So this is an average value. So at the moment of sampling, all the jobs took this amount of time. And this is different from individual job measurements. So this is aggregated. But if you go to the dashboards, so we have an OpenTelemetry logging dashboard, you see? So this is bundled with the Quarkus LGTM, and we can see the status of all the jobs that were executed, how many tasks were there when they finished running, and how long they took to execute. So this is why I say here in the code, the documentation, that it's queued plus running, because it spent some time queued and then some time executing, with the overall time of 17 seconds in this case. I don't know if you have any questions in there today.
There's
No,
nothing in the chat. No.
Except for a picture of a cat.
Okay. Yeah, the cat. So my cat wants to sleep on the router because it's warm. So.
Classic.
Yeah.
Have you got the source code in a shareable place for this?
Yes, it's. I will share the link later, but it's on GitHub. The whole thing. Okay, and now we can talk a bit. So about other things. I don't know how useful this is for most people, but I imagine that if a task takes a lot of time to execute, I will try to find out why. And the number of tasks running, it's a critical factor in here, because we have an executor that only supports 4 queues, 4 threads. But we don't have much insight on the behavior of the executor. That's why we can add a new thing here. So Micrometer has a binder specifically for executors. Has binders for many different functionality already, and in Quarkus we actually use a few of them, but we are not using this yet. And you can use an executor service metrics. And when you do, you can monitor with a registry. Oh, we need a registry. A registry. You can monitor in the registry any executor, in this case our own, and you give it a name for the executor. So in this case, maybe business executor, because it's not the stock Quarkus one, and we need to give it a name for the metrics. Let's go with demo business, because Micrometer will add other suffixes to it, and well, the simpler it is, the best. Okay, let's go. Not this one, this one. Let's go restart the whole thing again. Actually, yeah, I think we can restart the whole thing. So I like this one because I just need to click here a bunch of times. Let's go 10 and stuff will happen. Okay, it's starting to process. So let's increase the refresh. Logs, the maximum is 10 seconds. That's fine. Let's refresh. Okay, all of them are processed now. And we can see them here in the graphs. Cool. However, so let's collapse all these. On the executor side, we can see that the business executor had this many queue tasks at some point. We had 10, but the maximum that was sampled was 5, because some other work was consumed and some others were already running here. So we had 4 active threads in the maximum because we created an executor with only 4 threads, and then a bunch of threads had completed to the amount of 10, which makes sense because we had 10 jobs. And yeah, it adds all these basically for free, which is super convenient. And then on the long job service, we can use this information for other things. So it's actually hard to go here and understand if we get a very big spike here. So what did it happen? And when you are in the seeing the traces, you might need more information, because you see all the traces. You have one that took a lot longer than usual, and it would be handy to go there and have an idea of what happened. And you can do it by adding context to traces. We are going to see traces next, but yeah, let me show you something about it so you can understand. So traces in Grafana are available in the Explorer on Tempo, which is the database that stores traces. And we have a bunch of traces here. So each one of these lines is a trace. These traces are a bit boring because they only have one span. And this is the span related with the the post. So when we click long started, we post something, Quarkus automatically adds information for that. So information about so according to OTel's semantic conventions, OpenTelemetry semantic conventions, the code namespace is the class name for us in Java, and the code function is the method name, and some other relevant information. So resource attributes is static information that is defined in the beginning of the server when the server starts and doesn't change, and it's used to contextualize this execution on Grafana as an example. Because imagine that you have multiple services, multiple instances of a service, you could have that context in here. Okay, so now what we want to do is create something more interesting. And let's create a span in here for the long task. To create a span, well, we need a tracer, an OpenTelemetry tracer. Tracer. Okay, it's this one. If you add it to the constructor, it will be initialized. Yeah, cool. Let's take it here. And then we can do things with the tracer. Let's go and do something. Let's create a new trace, a new span inside. Good name, that's fine. Start span. So we created a span. But the span is useless unless we make it active. So, and we need a try catch for that. You'll see why. So you need to make it current. And while doing so, it will create a scope, which is an auto-closable and will close when this is done. And on the finally, that's always the only place you should make span end, because it's the only place that you are absolutely sure that, well, will be executed even if a problem happens. And now that we have a catch here, well, we can add information about errors if they happen. So we can record exceptions. And we can add information to the span. So we can go here, span, and add attributes to the span. So let's set an attribute here. Oh, the task ID. So this is a nice feature because you've seen the task ID that does something, is in the log and so on. It's a good attribute to have in there. The duration. It's actually not, because it will be more or less the duration of the span itself, so we don't actually need to record it. But a thing that is useful is how many active tasks were there at this point. So span dot set attributes active tasks. Yeah. Just for this to be consistent, let's create a variable for this. Okay. So there were these active tasks. And when we reload the whole thing, hopefully. So let me do a hello.
So you don't need to do anything in particular with that scope object?
No. The scope is just to limit the context of this span execution.
Gotcha.
And is not a closable, so you don't need to care about it. You just need to define it so it opens that context. Okay, so let's start a couple of tasks. And when we go here to the spans, okay, refresh. So this timer is a bit of a pain. Okay. Let's go for the last one. Now we have this trace has two spans. The trace ID is always defined by the first span created in the system, which in this case is the one at the rest endpoint. And then we create a new one. So what we saw last time. And then we create a new one on the job that has the attribute. So task 1 had two. So sorry, task ID 2 had one task active, which was this one. And we have the duration and so on. And if we are lucky, we can go to the logs. No, the linking is not working properly. But there's a cool thing that I want to show you, but I need to go to the chat. So we already have traces everywhere because we have endpoints. So if we go to the chat and just ask, say something like hello. It's not much, but the AI will return, hello, how can I help you today? That's fine, very polite. And on the metrics of the chat, we have this dot here, this special dot, which is an exemplar. So exemplars, when you are checking the metrics on a particular system, Micrometer will sample, will give you a trace as an example for that metric in particular. So in this case, the chat requests total, we can navigate to a span that is representative of that metric. And this is super useful if you have particular things that you want to inspect. You actually have an example of a request that matches that metric. And so this is the endpoint that goes to the AI. And thankfully, LangChain4j already has particular spans that generates automatically for us. So this is the automatic REST span equivalent to the previous one, but this for the chat endpoint. And then we go to the chat AI service. We don't have any span attributes, but when it uses the ChatGPT 4o Mini, which is the default AI that we are using here, model, gives you a bunch of data, including the estimated cost of that call, which is super handy because you can accumulate this eventually. And so the completion, so for the end of that call to the AI. And yeah, so basically you can navigate between the metrics and the traces if you have exemplars. And I don't know if we have logs for this. Probably don't, but we can add. So on the chat service, we can let's say using the logger, the famous logger from Quarkus that you don't need to define it upstairs. So
I love that logger, but some people get very angry about it.
Yeah.
I have your slide, Holly. Don't make humans tell the computer what it already knows.
Yeah.
Oops. So that's the answer.
I haven't seen info V before. I always use like info F.
That's the string formatter, but you have these semantics if you use the V.
So you have to
I like it.
Order.
Yeah, I like this more than the other one.
Yeah,
It just
I do too.
converts this to a string. Yeah.
Do we have one? I know a little off topic, but like remember the
Yeah.
old SLF for JLogger? You didn't have to order them; you just did the squigglies. Do we have something that does that, or do you have to like put 0, 1, 2, 3?
Oh yeah, you need. So this is the index of the attribute that you have here. And if you mess the attributes, if you miss one, it will blow up. So you need to be careful on that.
I'll have to play with it and see which one I like. I didn't know about that one. Learn something new every day. I learned about walking in an observability talk. I'm kidding. I learned a whole lot of other stuff too.
So hello. So 3 hellos. Hello. And if we go to the logs, so dashboards, logging, hello. So actually, it's quite interesting because you see, every time I say hello, it says something different. Like it's trying to make sense of me. So why are you repeating hello? And it tries different strategies to convince me to say something else. Interesting.
I wonder if you kept doing it, it would get angry at you. Like, dude, what are you doing, man?
I always wonder that with sat navs after like the 15th time when it's like turn left, no, the other left. They just there's no memory in those systems.
Why are you using me if you're refusing to follow my direction?
Yeah.
Okay, so we have here. So we are in the metrics. We go to a span representative of that metric, and then we go to the logs that we have for that span. So the whole circle, which is, well, super handy. And Grafana is doing a good work trying to unify all this. What else? Oh, automatic things.
So just time to, we're about 10 minutes over time here. But if you've got more to go, you can keep going. I don't know if people have to drop off.
Yeah, let's maybe at some point do an advanced thing. But I want to just show you that Quarkus micrometer OpenTelemetry metrics have a default dashboard that is bundled with the Grafana dashboard. And you can have access to a bunch of metrics about REST endpoints, JVM status, thread states, memory pools, and all kinds of things with garbage collection and so on. And each one of these dashboards is directed if you are using a particular extension. So this one, the Micrometer OpenTelemetry extension. This one is if you are using Micrometer with the OTLP registry from Quarkiverse. And this one, if you are actually using the most common Prometheus registry, the one where we need to pull the /q/metrics endpoint on the Quarkus server for metrics. So we just need to choose depending on the extension that you have. Maybe we could. Now we probably could add this depending on what you are using, but that's something for later.
Yeah. Feature request.
Yeah. So all the code is somewhere in here. Let me show you. So in the Quarkus lab, here. Micrometer OpenTelemetry LangChain4j. I don't know if I can place it on a chat public here, but
if you put it on the internal chat here, we can drop it in.
Okay, so it's this address.
Cool. Let's paste it in.
Yeah, and all the code that we've been talking today, it's already here. Maybe I've done a bit more than we have here, but I think it should be mostly the same.
Excellent.
Okay.
Cool. Well, thank you very much, Bruno.
You're welcome.
Yeah.
We'll have to schedule part 3, the advanced topics.
Yeah, and I'm going to go away and try some of these things. I've learned a lot as well.
Thanks very much. And if you have any questions, I think my Blue Sky Handler is somewhere in there. You can just pop some questions in there.
Yeah,
or on
excellent.
Zulip.
Or on
Zulip is
Zulip.
also good.
Yeah. If you go to Quarkus.io, and then there's a community section, and on there we've got all the coordinates for Zulip and various other things. And then if you go to Zulip, you can find Bruno.
Yeah.
So, yeah. Anything else from you, Eric?
No, I don't think so. This was awesome.
Yeah, really, really good. So yeah, thank you again, Bruno. And
Okay.
we will see you sometime for part 3, and we'll see everybody else next week. Do you know what we've got next week?
It's a good question.
Yes.
I can go over right to the website and let's see. It is AI assisted development with Quarkus Dev MCP with Philip and Ozan.
Oh, cool. Yes, people keep asking questions, and we keep saying, "Oh, you need to wait to the Quarkus Insights and see." So it should be a really good demo. Cool. Well, thank you all, and see you all next week. Cheers, all.
See ya.
Bye-bye.